I'd like to talk to you today about the graph of some of their exponential functions. In class today, I mentioned a few that you'll be required to know for the test, but mostly what I'm concerned about today is you understand how I arrive at stretches and shrinks and shifts and reflections and the many things we talked about in class today. And I'd like to examine some of those specifically with the parabola, which I think is the function that we talked about you're the most familiar with. So on the chart here, the one circled in blue, this is the basic graph or chart, of a parabolic function, or simply y equals x squared. Frankly, if I put in a 0 for x, I get 0 for y, right? It doesn't matter if I put in -1 or +1. When I square it, I get +1. And if same thing, if I put in a -2 or a +2, when I square it, I get a 4. And finally, the same thing for positive or -3, I get 9. Now I've gone ahead and graphed this basic function here for you. And what I want you to notice is that the basic function, I started right here at the origin. You can see because it's, red axes, and there's the origin. And of course, that's my 0, 0. And then as I move over 1 in either direction, -1 for x or +1, the y coordinate is also 1. So if I go over 1, I go up 1, and that's the coordinates 1, 1. But because if I square -1, I also get +1, -1, +1 also works. By the same token, if I move over 2, I put in a 2 for x. I get 2 squared or 4 for y, so that would be the coordinates 2, 4. If I go back to -2 and square that, I also get +4. And finally, if I go over 3 and square it, I get 9. And if I go back -3, I also get 9. So this basic pattern will hold for every graph. The basic pattern, the base graph, the parent graph of a parabola looks like this every single time. Now we just have to examine how different numbers that we can add to the equation affect it. Here's the first one I'd like for you to consider. What happens if I have x squared minus 2? Well, basically, y still equals the same old x squared it equaled back in this one, but now I'm going to subtract 2. So before, if it equaled 0, now it will equal -2. If it equaled 1 before, and I subtract 2, it'll equal -1. If it equaled 4 before, now it'll equal 2. And finally, if it equaled 9, it equals 7. And frankly, you could arrive at these numbers by simply plugging in. If I plug in a 0, like I said, the 0 squared part just gives me 0. -2 would be -2. If I put in a plus or -1 and square it, I get the same old 1 again. But now if I subtract 2, I get -1. And the point again is that all the values here are exactly what they were before, because to that point, again, the curves to that point, without the -2 that is, those graphs are identical. But when I subtract the 2, all the y values literally go down by 2. Well, how would that affect your graph? Frankly, I could simply come over here and just take every one of these coordinates and subtract 2 from the y coordinate. And this is supposed to be blue, but it's not showing up very blue. So that's not, to be honest, the way I would start it. The way I always find the graph is I start with the vertex. The vertex is 2 lower. So instead of here, my vertex would be 2 lower right there. From this point, all the other points are related exactly the same way. In other words, if you recall here, to get the next point, I moved over 1 and up 1. So here I move over 1 and up 1. When I moved over 2 before, I moved up 4. Well, I still move over 2 and up 4. And finally, when I moved over 3, I moved up 9. Well, once again, when I move over 3, I move up 9. And you'll see that the graph here is in each case exactly 2 lower than it was before. I've taken the exact graph and just lowered it 2. And of course I ignored it's exactly the same points on the negative side. So here's my parent graph, my father graph if you want to think of it that way. And here's the child graph, if you will. What happens when I take the original graph and, as you'll recall, subtracted 2? The effect was, again, the graph just literally lowered 2. What do you predict would happen with the x squared plus 2? Once again, what happens to all my y values? The y equals x squared values, you remember we had over here, 0, 1, 4, 9. Now they'll be exactly the same, but I'm going to add 2 to all those values. So 0 becomes 2, 1 becomes 3, 4 becomes 6, 9 becomes 11. As one student commented in class, can't I just go ahead and plot these points? And you absolutely could. But what I want you to see happens is this. Once again, the shift, if you will, is plus 2. So the graphs are going to move up 2. Now I'm going to do this one in red. And what I'd like for you to see is, again, I'm going to start with the origin. But remember what happened with that plus 2. I started 2 higher, so I'll start right there. And from this point, how did we find all the other points? Again, I went over 1, squared is 1. I went over 2, squared is 4. And I don't have enough room on this graph, but if I went over 3, squared would be 9. And I have the exact points that I had before, and my graph would look now 2 higher than it was before. And don't forget, negative 1 squared would also be 1. Negative 2 squared would also be 4, and negative 3 squared would also be 9. Remember, they're symmetrical about the y-axis. And once again, we have the 3 graphs. The original graph is here in black. When I subtracted 2, remember, it just lowered the whole graph 2. But what I did is I just started down 2 and used the same pattern that I always use. When I had plus 2, I just took my vertex and moved it up 2, and again used the same pattern. My preference is that you think about these principles on every graph that you do. Let's take a look now at another example. And let's specifically talk first about what happens with the numbers. Now, Luann, what I want you to see, or I want to ask you, I want to get, you'll notice, exactly the same answers that I had for y before. I want 0, 1, 4, and 9. My question is to you, what x will I have to put in here in order to get these same values that I had before? What would I have to put in here for x so that when I take that number minus 2 and square it, I still get 0?
2.
And of course, you're right. That answer is 2. Let me change back to black here for a second. And we're just going to talk about the positives the way you're very naturally doing right now. 2 minus 2, of course, would be 0. Squared is 0. My next number I want to be a 1. So again, what number would I have to subtract 2 from, square it, and get a 1?
3.
And of course, 3 minus 2 would be my 1. Squared is 1. Now, do you see what's happening here? This next number, I want to be a 4, so this has to be my 2 squared. So what number will you have to put here in order to get a 2?
6.
So 6 minus 2 would be 4. Squared would actually be a 16. Remember, I need this parenthesis to be a 2, so that when I square it, I get a 4. So what number will I put here for x?
4.
So 4 minus 2 would give me my 2. Squared would indeed be a 4. And I'm hoping you can probably even see the pattern here, frankly. What number minus 2 would square to be 9? Of course, the inside would have to this time equal a 3.
5.
So that would be a 5. Minus 2 would be 3. Squared is 9. Here's the important thing. You have to remember that you're going to subtract 2 from all these numbers. That means they have to be 2 higher than they were before. So instead of 0, you had to put in a 2. Instead of a 1, you had to put in a 3. Instead of a 2, you had to put in a 4. Because the first thing you did was subtract 2 from that number, and you're right back at your original x's. So once again, it's exactly the same pattern that we've had the whole time. I want you to realize that this time, where am I going to start? Well, normally, frankly, I would start right here at my origin. And just to be clear, let's go ahead and draw my axes again in red. But what I need to ask again is, what was the effect of this minus 2? This meant all these x values actually had to be what?
Positive.
They had to be, we did only look at the positive values, but compared to what they were before, you had to do what to all of these values?
Add 2.
You had to add 2. You always have to do the opposite. So instead of thinking of this as actually subtracting 2, which would kind of move it to the left, you need to actually shift the whole graph plus 2 to the right. So instead of your vertex being right here at the origin, the way it always is, I have to move it out here to the right 2, because there is a shift to the right of 2. Now at this point, the graph is the same as it was before. What do I do from this point? How do I get my next point? I come over 1 and up 1, because 1 squared is 1. When I come over 2, Luann, how far up do I come?
2.
Remember, our base curve is y equals x squared. So you're having to square whatever number you put in. When you put in a 1, you got 1. But when you put in a 2, you get 4. So when I move over 2 for my vertex, I have to come up 1, 2, 3, 4. And when I move over 3, 1, 2, 3 for my vertex, I get
9.
1, 2, 3, 4, 5, 6, 7, 8, 9. Now I've concentrated on the positive numbers, but remember, it's symmetrical about the y-axis. If I move to the right 1 and up 1, I could also think of that as negative 1 squared is 1. And negative 2 squared is 4. And negative 3 squared is 9. But remember, I'm doing the pattern from my new vertex, which I know has moved over 2 to the right. But the same pattern of 1, 1, 2, 4, 3, 9, and the reverse on the other side, on the negative sign, still exists. So the key is just to find out where the vertex is, and then everything else is the same from that. So my graph in this case would look like it's the same old, frankly, parabola I've had before, but now it's shifted to the right 2 places. Let's take a look at our last one here. What do you predict would be the effect of adding 2 to all these values? I still want y to be 0. So inside here, this would have to be equal to
0.
And to get that to be equal to 0, what will I have to actually put in for x?
Negative 2.
And to get this to be equal to 1, so that when I square it I get 1, what value would I have to put in there?
Negative 3.
Negative 3 actually would work, Luann. If I put negative 3 plus 1, it would be negative 1, which squared would indeed give you 1. But keep in mind, we're just looking at the positives for right now. So what number would I put in for x so that x plus 1 would equal positive 1?
1.
Negative 1. Because negative 1 plus 2 would be 1. Squared is 1. And when I want this to be squared to equal 4, the inside has to equal 2. So what will I put in for x?
Negative 4.
Well, now you're thinking the negative values again, and I don't want you the negative values. I want the positive values. What would you put in for x so that this equaled positive 2.
0.
0 plus 2 would equal 2. Squared would be 4. And finally, what would I put there to get a 3? So when I square the 3, I get my 9.
1.
And once again, if we go back to these original values we had, do you see how these compare? The 0 became a negative 2. To get a 1, you actually put in a negative 1. To get in a 2, you actually put in a 0. These numbers are all what compared to their original numbers? And let me just write the original numbers here. They were 0, 1, 2, and 3. These numbers are all how much smaller?
2.
They're 2 smaller. So again, even though you see this plus 2 and you're sorely tempted to move that graph to the right 2, you need to think about what number would I put in for x to still get what I had before. So the effect is actually opposite. You need this to be a 0, so you actually have to put in a negative 2. You have to lower the value by 2. You always end up doing the opposite. So once again, on our last one, we saw this was a negative 2. Recall, that shifted the graph to the right 2. So when we put in the plus 2, we figure, logically, that this will shift our graph in which direction, Luann?
To the left.
To the left 2. So again, instead of starting right at the origin the way I normally do, I'm actually going to start over here to the left 2. But the pattern still holds. If I start here and I move over 1, I move up 1. If I start here and move over 2, how far up do I move, Luann?
4.
And if I start here and I move over 3, I move up?
9.
And again, even though we've been ignoring the negative values, they work as well. Negative 1 squared would be 1. Negative 2 squared would be 4. And negative 3 squared would be 9. And now my other graph, which I'll do in red here, just to keep them distinct. And of course these go on forever. If I forget to put those arrows, they always need to be there. On the test, truthfully, a few points, a couple on each side of the vertex is going to be fine for me. On WebAssign, they're only going to require you 1 point in addition to the vertex. So again, here's the key. My basic graph, you'll recall, if I go all the way back to the beginning, was centered at the origin, and I went up 1, over 1, up 1, over 2, up 4, over 3, up 3. Up 9, excuse me. That same pattern holds, I'm just moving it around. Originally, I moved the graph up or down, and it was very logical. If you had a minus 2, you moved the graph down 2. If you had a plus 2, you moved it up 2. It's harder with the x's. You have to think in reverse. So if inside that parenthesis you're subtracting 2 from the x, that really means the graph shifts to the right. And if you're adding 2 to the x, that means you're really shifting the graph to the left. So I ended up with the minus 2 shifted to the right, and the plus 2 actually shifted to the left. Now there's a couple more things I'm going to want to show you here. Let's keep on going. So far, all we've done is shifts. Now I want you to consider some other things. What about this? What about y equals x squared still? But now I'm going to put a negative sign in front of the x squared. I still get my 0, 1, 4, 9, just like before. 0 squared is 0, 1 squared is 1, 2 squared is 2, 4, 3 squared is 9. But with a negative sign in front of these, Luann, what's going to happen to all these values? Instead of being 4, now it will be negative 4. Instead of having 9, you'll have negative 9. Instead of having 1, you'll have negative 1. All the values, frankly, simply become the opposite. If they were positive, now they're negative. How is that going to look on your graph? Well, frankly, when we make a graph, we'll start right there at the origin. Normally I go over 1, over 2, up 4, over 3, up 9, 5, 6, 7, 8, 9. And of course the same thing if I go back 1, back 2, I go up 4, back 3, I go up 9. Now, what is going to happen to this graph, do you think? if I put a negative sign in front of all the y values. Instead of going up, I will literally do what?
It's going to go down.
It's going to go down. You can literally, if you want, take the easy way out. Just take the graph and flip it over, and ta-da, you're done. But, to be honest, for our purposes today, let's talk about this. Instead of, when I go over 1, instead of going up 1, I just do now the same thing, but I go down the 1. When I go over 2, instead of going up 4, I simply go down 4. And finally, when I go over 3, I go 5, 6, 7, 8, 9, down.
Did you put your axis in there?
I will absolutely put my axes in there to help out Luann here. I know all the students were completely with me, but just to help Luann because she's my slow learner. And of course on the negative side, again, I have the same points. And there's my graph. Exactly the same thing I had before, but as I pointed out, instead of going up, it now goes down. Now, let's talk about a different change. This time, instead of putting a negative sign in front of it, I've put a 2 in front of it, which literally means I'm going to multiply all my x squareds by 2. So instead, if we go back to this beginning one, their basic function, if you remember here, if I just cross out that 2, what kind of values do I get? Again, it's the same values over and over again. If I just square these, I get 0, 1, 4, and 9. Putting that 2 in front, how is that going to affect them? Well, 2 times 0 isn't going to affect anything. But 2 times my 1 squared would give me
2.
And instead of 2 times 2 squared, instead of being just 4, it will be 8. And 3 squared is normally 9, but times 2 would be 18. So, on the same graph that I just used, how are these values going to change? Now, I won't have enough room to do as many points, frankly, this time. But normally, if I think of this graph again as my standard basic parabola, normally I'm going to start at the origin, and I still am, by the way, because we didn't move left or right, up or down. So I'm still going to start right at the origin, but what do? I normally move over 1 and up 1. But remember, I'm doubling all these values. So instead of moving over 1, I'll move up, Luann, 2. And normally when I move over 2, I move up 4, but now I'll move up
8.
And of course, if I move back 1, the same thing. Double it, back 2, double it. So instead of moving again up 1, I move up 2. Instead of moving up 4, I moved up 8. And now we refer to this as a stretch, usually. Because what I've actually done is I've taken that original parabola and I've stretched it to twice its normal size. So see, what was it 1 is it 2, what was it 4 is now at 8, what was it 9 won't even fit on my paper. It would be way up here somewhere. So again, it just makes it longer and skinnier. Now what would the effect of my next one be? What if I multiply them all by 1/2? Again, my base function was 0, 1, 4, 9. The 0 won't be affected. 0 squared is still 0. Taking half of it is still 0. But how about the 1? 1 squared would normally give me 1, but if I take half of it?
Half.
And normally, oops, wow, these are my regular values here. I'm so sorry. They're not even my regular values. I was just trying to fake out Luann there. Actually, what I did from before was just give a cut and paste, and I shouldn't have done that. 1 squared is 1, times half is half. Normally, 2 squared would give me 4. But now when I take half of that, I'm going to get
2.
And normally when I take 3 and square it, I get 9. But if I take half of it, I get
3.
Half of 9?
Oh, 4.5.
4.5. So let's talk about this and how it looks on my graph. I'll do this graph in red. Remember, this blue was my stretch where I doubled all the values. This has just the opposite effect. Instead of moving up 1, normally again I move over 1 and up 1. Now I'm going to move over 1 and only up, Luann, a half. And when I move up 2, normally I go clear up to 4. But since I'm taking half of all my values, when I move over 2, I only move up
2.
And instead of moving over 3 and moving up my normal 9, now I just move up
4.5.
4.5. And you know what? It just occurs to me I could even go one more value now. I could go out to the 4. Normally squared would be 16, but since I'm taking half of it,
That'd be 8.
solve a point there. And again, I've only paid attention here, just to make my life a little easier, frankly, to the positive values, but you have the same effect on the negative side. Negative 1 squared, half of that would be would also be 1/2. 1/2 of my 4, 1/2 of my 9, and 1/2 of my 16. And you notice this graph, compared to the parent graph, if you will, is flatter and shorter and wider. I think all of those adjectives actually applied. And we think of this as a shrink. Somebody in class today called it a compression, and I actually kind of like that word more because I've actually taken the graph and compressed it into a smaller graph that in this case is literally half the size. Alright, now it's time for a challenge here. Let's talk about this graph, Luann. This graph has I'm sorry, I put the square in the wrong place. I am having all kinds of trouble trying to get this tape up and posted for you folks to help you out. That squared should have been on that. Again, this is my basic function, is y equals x squared. Well, what's the effect of the negative 3 going to do? Again, if you subtract 3 from all those values, and remember, if it's not inside the parenthesis, you need to think of how it affects the y. So the minus 3 does what to all my y values?
Lowers it.
By 3, right? And now how does the plus 2 affect my x values again? Because it's inside, you have to remember it has the opposite of effect. So you have to think, what do I put back in here? Truthfully, I always think about my origin. What do I need to do to be back at the origin again? What number would I need to put back in here to get my 0?
Negative 2.
This literally shifts it to the left 2 then. Instead of being at 0, you're over at negative 2. It always does the opposite. So this would go to the left 2. This does exactly what you would think, because y equals this. I'm just going to subtract 3 from that value. So it goes down 3, and it goes to the left 2. So let's go to our graph. Let's put our origin right here in the middle of the paper, more or less. I'll go ahead and draw my axes in again in red. Normally, that's where my vertex would be, right at the origin. But remember, let's go back to our equation again for just a second. Where do I have to move my vertex? Like every point on the graph, it'll move to the
Negative 2.
It'll move negative 2, which means to the left in the case of x, and the y value will make it move, well, if it's going negative 3, on the y value, I go down 3.
Down.
So this goes to the left 2 on the x-axis, but the y value goes down 3. So instead of being right at the origin, I go to the left 2, down 3, and I'm right there. Now the pattern is the same as it always is, and this is why I really emphasize doing it this way. I'm done now with this graph. That is all you have to figure out. To find my next point on a parabola, what do? I move over 1 and up.
1.
And if I move over 2, I move up.
4.
And if I move over 3, I move up
9.
5, 6, 7, 8, 9. And again, exactly the same thing would happen here on the negative side. Oops, sorry, for those of us who can count, that would be there. And finally, up there. And let's go ahead and make this graph in blue again. And obviously from my artwork, you can tell I'm not going to be real fussy with the accuracy of your graphs as well. Final exam time. Where will my vertex be? Normally it's 0, 0. But the x I have to move to the, remember it does the opposite, Luann. So instead of minus 1, I have to move it
Positive.
which moves it to the,
Right.
and the y value, because it's outside the parentheses, would normally do what now?
Go up.
Go up 7. And it does. You don't do the opposite on the y, just on the x. So my vertex, I'll move to the right 1 and up 7. So here's my, I'm going to use the same graph again. Here's my origin. I'll move to the right 1 and up 1, 2, 3, 4, 5, 6, 7. And let's go ahead and just circle that in red so that we keep track of where we are. That's my starting point. Now what I've done to you though this time is look at this. That's not the only change. I've also got this -2 out in front. Now remember, if it's not inside the parentheses, you want to think about what's the change on the y values. What's the negative going to do to all the y values?
Take it to the left.
Now the y values go up and down. And by multiplying by a negative number, you've made all the y values negative.
Down.
So now they go down. Not only are they going to go down, though, I've multiplied them by 2. So they're going to go down twice as much as you normally move. So let's go back to our graph. Normally, once I start here on a normal parabola, if there was no -2 there, I would just move over 1, up 1, over 2, up 4. But remember, I'm moving the opposite because of the -2. I'm going to move down twice as much as normal. So normally, when I move over 1, I'd go up 1. But now I'm going to go
down 2.
And that would put me here. And normally, when I move over 2, I would move up
4.
But now I'm going to move down
8.
And if I wanted to do one more, normally I'd go 3, but I'm running out of room here real fast. Normally you go 3, I would go up 9, but now I'll go down
18.
Which would take me off the bottom of my graph, so I'm not even going to bother. And again, just a couple points on each side of the vertex is going to be good enough for me. And again, if you move over 1 and down 2 this way, you'd have one on the negative side as well, here and here. And now this graph will look like this. That's about as tough as they're going to get right there. That -2, again, the key is it flipped all the values over and doubled them.